So you've successfully installed Klipper on your machine and you're ready to go ahead and start pushing plastic. However, there is a few things you're going to have to configure and tune before you do your first print. And also there is an order of operations when it comes to doing your initial setup with Klipper. If you do things out of order, you're going to have a bad time. So let's get started. Now for this video, I'm going to be using Fluid as my interface of choice, as that's what's installed on this machine I recently built. This is the Voron V1.8. However, this guide will apply to pretty much any machine you've installed Klipper on and any of the interfaces as well. I do recommend following along with the documentation linked in the description if you have any questions or any concerns with any of the steps going forward. As this video will be more of a general overview of the steps and the proper order to do them in. So one of the first things you're going to want to do on power up is ensure that your heaters are properly set up and configured. In my case here, I only have a single hot end heater and a bed heater. You're going to want to ensure that both heaters are reading roughly the same temperature as well. For example, if your bed heater is reading 60 and your hot end heater is reading 20, for example, odds are the bed heater is incorrectly configured. So you're going to have to go ahead and correct that. Once they are corrected and they're reading both roughly room temperature, I do recommend telling them to heat up. You don't have to heat them up much. Set your temperature for each one to about 50 degrees Celsius and just ensure that they are responding and heating up. Once you see that you do have some response, everything's heating up and turns off when you tell it to turn off, you're okay to move on to the next step. Now the next step is very simple. With the machine powered on, grab your tool head and just kind of move it around. You're going to want to make sure that all your axes, X, Y, Z, and extruder can move freely by hand with the motors powered off. If you have a motor that does not move, odds are it's either a wiring issue or a firmware issue. The first and simplest method to check is going into your firmware. The reason this can happen is an improperly configured enable pin. To correct this, just look at the enable pin for the motor in question, either add or remove an exclamation mark before the pin assignment. This will invert the pin, and hopefully after a save and restart, everything should move. If the pin is configured correctly though, and you are still not getting any motor movement, it may be a wiring issue that you'll have to correct. Now once you ensure that your motors are set up correctly, you're going to have to check your end stops next. Now you can either run the query end stops command through your terminal, or in Fluid, for example, there is an option for directly seeing the results of your end stops. So what you're going to do is you're going to pull all your end stops at once and ensure that without anything touching, they're all in the open state. If they are in the triggered state, when they shouldn't be triggered, you're going to go into your config and either add or remove an exclamation mark before the pin assignment for the end stop in question for that axis. Once all your end stops are reading open with nothing in contact with them, you're going to go ahead and activate each end stop individually and check the readout afterwards. You want to make sure that all your end stops are triggering. Now you can do this two methods, either by pushing the end stop directly, or what I like to do is actually move the tool head or whatever will trigger the end stop against the end stop. This confirms that one, the end stop functions, and two, that you're going to get proper motion out of your printer. The last thing you want is to home your machine and have a cable shroud or a zip tie blocking the movement and causing the printer to error out. Once your end stops are configured, the next thing we're going to do is check our motor direction by doing what's called a stepper buzz. The stepper buzz command basically tells the motor to move in the positive and the negative directions a very small amount several times. So for example, on my printer here with a bed moving in the Z direction, the bed will drop down and move up, drop down and move up. If you notice the motor moving in the opposite direction to what you want, the easiest way to fix this is simply invert the direction pin in your configuration. So go into your config for the motor in question. For your direction pin, put an exclamation or remove the exclamation mark before the pin, and this will invert its direction on a save and restart. Now on a multi-Z printer such as this or my Voron V2, which has 4 Z motors for example, you need to check each motor individually, because the last thing you want to do is have motors moving in opposite directions during an attempted travel move. This can cause damage to your printer. So you're going to want to go through and check each motor individually and make sure they are traveling in the correct direction when commanded. So our end stops are set up correctly and our motors are moving in the proper directions. The next thing we're going to do is attempt our first home. So the steps for this depend on what kind of printer you have built, but I'm going to be using my Voron V1 here as an example. Now on the Voron V1, the X and Y home traditionally, and then it homes its Z off of a Z micro switch installed next to the bed. So what I'm going to do is home my X and Y first. Once homed, I'm going to move it to where it needs to be for homing the Z. Make a note of what the X and Y coordinates for that are. I'm going to go into my configuration, edit the line that is required for the safe home position for the Z to that coordinate, save, restart, and then I'm going to home my XY again, and then I'm going to ensure that I can do a safe Z home afterwards. Now with a core XY motion system, odds are, and if you're like me, you're never going to be lucky in your first attempted home, your tool head is going to go in the wrong direction. In a core XY based system, the motors work together or opposite of each other to get motion. So what can happen is if your A and B motors are not running in the correct directions, you're not going to get the proper motion. This can be corrected by either inverting the motor direction for one motor, both motors, or in some cases you even have to swap the plugs in the controller board to get the correct motion. Now there are pictures showing how to correct this and the troubleshooting steps on the Voron website, and I do have a link below for that as well. So now our printer is homing successfully, we're getting correct motion, and everything's moving properly. The next thing we're going to do is calibrate our PID tune for the hot end and the bed. Now calibrating your PID tune is a very simple process. What I would recommend is putting your tool head in a safe position, usually in the middle of the print volume, and you're going to run a command to calibrate your PID tune for the hot end, and then afterwards a PID tune for the bed. When you do PID tunes for your hot end and bed, I do recommend PID tuning as the printer will run most often. So for example, if it is a printer that will mostly print PLA, PID tune your hot end at 200 degrees Celsius with your part fan on high and tune your bed at say 60 Celsius. In my case here, where I print a lot of ABS, I do my PID tune at 245 Celsius with the fan on 20%, 110 on the bed, and I tune with my printer fully enclosed. The reason for this is your PID tune will be most accurate if you tune it for what the printer will most often be experiencing. And the next step after doing a PID tune is with our hot end, which can now heat up properly, we're going to check our extruder calibration. Now when it comes to calibrating your extruder, there is a ton of old wives' tales, community knowledge, he said, she said, or I've always done it this way, that's how I'm going to keep telling people to do it, and they're going to keep telling people to do it because that's how they've always done it. Really, when it comes to calibrating your extruder, what you are setting up is when you tell your extruder to push 100 millimeters of plastic, it pushes 100 millimeters of plastic as accurately as possible. Now, if possible, you're going to remove your hot end at this point, or if it's a boat-in setup, you're going to disconnect the boat-in from the hot end. You are going to be extruding into open air. Now, if your printer setup does not allow you to remove the hot end, or you're uncomfortable playing with electrical, I would recommend extruding slowly and with a hotter than normal hot end, just to ensure that you're minimizing any potential for interfering with the motion of the extruder itself. Now, the reason we are doing this is because we are calibrating just the motion of the extruder. We are calibrating just motion. We are not calibrating flow. We are not doing any of that. That will come later. And we will not be calibrating these steps based on any printed object. Calibrating motion of a 3D printer based off an imperfect object, such as a 3D print, is not the correct way to do things. Now, when it comes to adjusting the motion of the extruder, you're going to tell it to extrude 100 millimeters of filament. You're going to ensure it's moving in the correct direction. If it's not, go ahead and invert the direction pin in the config for the extruder motor. And you're going to measure it. If your extruder is extruding the correct amount, you're good, you can move on to the next step. If it is not extruding the correct amount, you're going to have to go into the config and you're going to have to adjust its value. Now with Klipper, you may notice it's a little bit different than other firmwares. Whereas other firmwares work off steps per millimeter or millimeters per step, Klipper works off of rotation distance. Now at first, this may seem a little bit weird and confusing, but on paper, and once you work with it for a bit, it makes a lot of sense. Essentially, you are telling the printer the raw data and it's doing the calculation to adjust E-steps automatically. So you don't need to do any, I'm running at this many microsteps, what is my E-steps now? All rotation distance is telling the printer how many microsteps I'm running, any gearing involved, how many full steps does it take for the motor to do one rotation. So for example, a 1.8 degree stepper is 200 steps per rotation. A 0.9 degree stepper, 400 steps per rotation. And lastly, you're telling it how much linear direction one full rotation is. So for a 20 tooth 2 GT gear, for example, one full rotation is 40. For a TR88 lead screw, one full rotation is 8 millimeters of travel. A TR84 lead screw, one full rotation, 4 millimeters of travel. So you're basically telling the printer what these stock values are, and then it'll automatically calculate your E-steps. This is very handy for motion systems that aren't strictly linear, so you may not really need all the full benefit of this, depending on your printer, but things such as a puller printer take more advantage of this. Also, if you decide to play around with your micro-stepping, you don't need to recalculate your E-steps. All you just do is tell it the new micro-stepping, and it does all the math for you. So when it comes to adjusting your extruder value, you're going to be adjusting just the rotation distance number. So you're going to do your math on either if you need to increase or decrease your rotation distance value for extruder to calibrate your extrusion flow until when you tell it to extrude 100 millimeters of filament, it extrudes 100 millimeters of filament. Now, after your extruder distance is calibrated, I do recommend just ensuring that your XYZ distance is correct. So use something such as a ruler, tell your printer to move 50 millimeters in each direction, and ensure it's moving that correct amount. Again, you should not be adjusting any of these values based off of a printed part. There are way too many variables that can affect the dimensions of a printed part, and using that to adjust the motion of your printer itself is not the correct way of going about it. Also, don't forget, if your printer has some sort of feature, such as a quad gantry level, a Z tilt on a dual Z setup, or a bed mesh, you're going to want to head and go and ensure that those are properly configured as well. On most of the stock Voron configs, it's either pre-set up automatically, or you're just going to have to go into the config and uncomment the sections that pertain to the build size that you have built. If your printer's default config does not have this set up yet, or this is a new build and you're going to have to manually input these, I do recommend checking out the Klipper documentation on the GitHub for how to properly set this up, as I won't be covering that in this video. So to recap, at this point, our end stops work, our printer homes, our motion is in the correct direction, and it's moving the correct amount, and our extruder can push the desired amount of filament when we tell it to. Also, our PID tunes are done. So what can we do next? You're gonna print something. This is a brand new printer. Print a benchy, print a cube, print a bunch of benchies, print a bunch of cubes. You're gonna wanna put some time on the printer right now. There is still some more tuning, and I'll get to that in a second, but you wanna get some time on the machine. You wanna make sure all your screws are tight at this point. You wanna ensure your belts are properly tensioned at this point. Stuff needs a little bit of a break-in period, especially with a brand new build. You wanna make sure, hey, you didn't forget a bearing at some point. You wanna make sure everything is working properly, so you're gonna print something. You might have some issues with the print. Again, you're not fully tuned yet. However, you wanna make sure the machine itself is behaving properly. Now after that, then we can move on to the fun stuff. Now there's two more things I wanna go over: pressure advance and input shaping. What input shaper does, it allows your printer to be tuned to cancel out resonances that happen at higher speeds and higher acceleration. This allows you to print faster with minimal ringing. And the other thing is pressure advance. Pressure advance is adjusting the flow of filament through the nozzle as you print. This can lead to sharper, cleaner prints, less blobby corners, and cleaner retractions. Now with those two, there actually is an order of operations to them. You have to do your pressure advance tuning after your input shaper tuning. The outcome from your input shaper tune will affect your pressure advance value. Usually it lowers it. So what this means is if you're not doing an input shaper tune right now, you don't have the accelerometer, you don't want to do it just yet, you can go ahead and do your pressure advance tune. However, if you do an input shaper tune in the future, you're going to have to take a step back, redo your pressure advance after you do your input shaper tune, because the value will change. Now I do have full videos on both of these, so I'm just going to touch on the basics of doing an input shaper tune and a pressure advance tune, and some new features with input shaper. Now with input shaper, there's two ways of tuning it, with and without the accelerometer. Without uses a test print like pressure advance, and you do some measuring. I do highly recommend though that you do the input shaper tuning with the accelerometer. The results are much more accurate and it's actually a quicker process. The first thing you're gonna have to do is connect the accelerometer to your Raspberry Pi. You can see here on this image how to easily hook it up, and you are gonna wanna use wires that are long enough to reach from the Raspberry Pi to your tool head with some slack. Now, when it comes to mounting your accelerometer, you are going to want to mount it to your tool head as rigidly as possible. If you use something like double-sided tape, the little bit of flex that double-sided tape has will affect your final results. So you're going to want to screw it down at least. Ensure you don't short anything. And the easiest way is remove a screw and use a longer screw to mount it. Some tool heads do have the option for permanently mounting this. However, that's not really required because once the tune is done, you don't really need this installed anymore. Now, you are going to have to install some software to make this work. So you're going to have to log into your Raspberry Pi with something like PuTTY. You're going to have to run some commands. Just follow along with the instructions here. And you're also going to have to install your Raspberry Pi as a secondary MCU within Klipper itself. So just follow these two sets of instructions. It's mostly just copy and pasting until it is installed and you can restart Klipper. So once everything's installed, everything's set up, and you're not getting any errors, hopefully, you are going to run accelerometer query. This will give you a readout just to ensure that it is talking to the accelerometer and everything's reading correctly. Now, I do highly recommend reading through the whole document here on Input Shaper and how to properly tune it. There's a lot more in-depth information there. However, I am going to recommend that you start off now with just the simple auto calibrate with Input Shaper. On my previous video where I covered input shaping, I showed you how to do it manually, read the charts, and select a value. However, the Shaper Calibrate feature, which is the automatic input shaper tuning, is much more robust than it used to be when I made that video, and that's actually what I'm using on this printer right now. Put your tool head in the middle of your print volume and just run Shaper_Calibrate. Let it do its thing and read the output. So once this is done, it will spit out the values for the different kinds of input shaper per axis and its recommended final input shaper. Now, do be aware that the more aggressive input shaper you go with will lead to less ringing. However, it also leads to rounded corners. So unless you absolutely need an extremely high value input shaper, I recommend that you run one of the lower end input shapers such as ZV. I run mostly MZV on my printers. Yes, you won't be able to push quite as high of a speed. However, you're still going to get those crisp, sharp corners with it. So you can just do save config at this point to save those values. What you can also do is manually adjust them. So after you save it, if you do decide you want to drop down from say 2 hump EI to an MZV, just copy and paste that value into your config and adjust it. Another handy tip is on a belted system like a Core XY, you can run into issues with the results from Input Shaper if you tune at over 100 megahertz. You can limit that. How to do that and more advanced information about Input Shaper tuning is in the documentation, so I highly suggest you read that. And lastly, Pressure Advance. This is a very simple thing to tune. There's built-in macros to Klipper to do your Pressure Advance tune. And again, I do have another full video on my channel on how to do a Pressure Advance tune. So I'll just touch on the basics. You're gonna slice and print the test print off of the Klipper GitHub here. You're going to want to slice this with some certain settings. You're going to want to print it at 100 millimeters a second, 1 to 2 walls, no infill, no top layer. You're going to turn off any dynamic acceleration control, and you're going to print it at a coarse layer height. So for example, on a 0.4 millimeter nozzle, you're going to print it at 0.3 millimeters of layer height. You're going to run the command to set your velocity limit with Klipper, and also you're going to run a command that will adjust your pressure advance as the print goes on. There's 2 different commands here, one for a Bowden setup and one for direct feed setup. Now, once your print is done, go ahead, take that off the bed. Don't do what I did and print ABS open air in a room with a fan. You're not gonna be happy with the results. But once you have a successful print, you're gonna go ahead and take a scale and you're gonna measure from the bottom up to the sharpest corner on the print. And you can hold this under the light in different directions, and you're gonna have to make a judgment based on the appearance of where that point is. But you're gonna see a point where the corner is bulged. It'll get really nice and sharp and crisp, and then you'll also see it'll start to string out again as it's under extruding at that point. Once you find and measure the distance from the bottom to the cleanest point of the print, you're going to do some very simple math, and that is going to be your input shaper value. Add that to your config, hit save and restart, and you're good to go. At this point, your printer is pretty much set up with its introduction tune for the firmware itself. Now, of course, there are much more things you can do to properly calibrate and tune a printer, and I haven't even touched on any slicer tuning stuff. So when you print something and your walls are a little thick, you're going to be adjusting that in your slicer. So I hope you found this video helpful. I do highly recommend that you read all the documentation in the description below and watch the videos on Input Shaper and Pressure Advance that I have on my channel as well. There is much more in-depth knowledge in those videos and in those documentations and what I covered on the video today. This video, again, was just kind of a quick overview and covering the order of operations and the things you need to do before you start printing with your printer running Klipper. I hope you enjoyed the video. If you want to help support the content I create and the things I do have links in the description as well. I hope you learned something today, and as always, have a nice day. Thank you.